say this call is being recorded for quality and training purposes.
Yes, so I started the recording. I'll just give a brief introduction and then we can then over to you.
All right.
So, welcome guys, welcome everyone. Warm good afternoon to all of you.
Yeah, good afternoon.
This- Welcome to this webinar on artificial intelligence and testing from Verity Software. So this is around a 60 minutes webinar with 40 to 45 minutes of the presentation and followed by 10 minutes of Q&A. We thank you all for joining this webinar. The presenter for today's webinar is Vipul Kochar. Although no need of introduction to Vipul, but still I'll give a brief introduction about him. He's an ex-Adobe engineer and an IIT alumnus. He's having a 25 years of experience in software development and testing. He's a mentor, an entrepreneur, and a leader. He's the founder of Verity Software and Salt. He's the president of Indian Testing Board. He's the convener of Step In Forum and the national convener of Indic Academy. He's among the first testers of India, where he started his career in 1995 in testing. He is the inventor of Q patterns and linguistic analysis technique for test design and reuse. He is a thought leader,
Thank you, sir.
author
Thank
and
you.
creator of mobile
Anilji,
applications.
Anilji,
Small
thank you.
last line. He is the creator of AIU, the world's first AI testing certification, cloud certification on DevOps, and many more.
All right. Thank you so much.
And
Thank you.
just a brief
I would,
overview of the webinar, if you are okay with it.
yeah. So I will start now. I will mute everyone. Okay.
Okay. Yeah, sure. No problem.
So Anil, you can mute everyone, please.
I'll do it.
Thank you. There is a mute all. Okay. So I muted everyone. Thanks. So guys, welcome. It's a pleasure having you all here. We are going to talk about what is AI and how do you test AI and how to use AI in testing. So essentially you can see that in next 45 minutes, maybe 25-30 minutes would be spent explaining what is AI and what is machine learning and so on, show you a bit of hands-on. And after that, how do you test it? And then finally, we'll talk about how to use AI for testing, including things like ChatGPT. But minutes, 15 minutes. So let's see if I can do justice in that time. First AI testing certification called AIU, which is now adopted by ISTQB as one of the syllabuses for ISTQB AI certification. And these are the three persons who created world's first AI testing certification, which was translated in 7 different languages and thousands were certified. So you would be happy out of India, an international certification. If you look at AI, that's it's become a household word. Of course, engineers, people in software industry already knew it, but with ChatGPT, almost everybody, including your neighborhood chaiwala, understands or at least has heard the name ChatGPT and AI. So before we get into things, we need to understand what is the type of data on which AI gets applied, especially machine learning. So speech, so that is audio or speech processing, like your Alexa. But then Alexa not only converts your speech into text, but you also need to do natural language processing to understand the meaning of that. So that is NLP. And you have computer vision. So anything related to pictures, videos, you are talking about computer vision related data. And then you may have structured data, tabular data, like data coming from a database or CSV file and so on, typically used for predictive modeling and many other things. So these are different data types that you typically use in applications built using AI. Of course, AI is there, it is supposed to be very powerful, and so on and so forth. But take a look at some of the AI bloopers. Um, so there, in automated driving systems, ADAS, you have these driverless cars, and if they look at the stop symbol, for example, they have to stop, right? But just by placing certain white and black occlusions, basically tapes, white tapes and black tape, at specific points on that stop sign, they were able to fool the camera or the AI model looking into the stop sign into believing this is 45 kilometers an hour speed limit, right? So if somebody can hack these systems so easily, then there is a challenge there. Take a look at this. We have an AI system which is basically doing what is called as object recognition. It tries to recognize different types of objects within a given video. And here you can see it is trying to recognize a human being and a chair, only one at a time, probably, correct? So is it a limitation of the system that it can recognize only one thing? Because the other guy is trying to point to himself and saying, hey, I'm here, but it is not really doing anything. So, what exactly could be going wrong? Now, you see here that this guy turns this picture around and suddenly is being recognized. That means just this picture being there, the guy was not recognized as a person. Just imagine if I can print this on a my T-shirt, and I walk in, and the AI fails to recognize me as a human being, right? Uh, in a security system, that would be a big problem. So there are a lot of such interesting AI bloopers that are there. You need to be careful. And of course, on the other spectrum, people think that AI is out there to take all jobs away and it's going to take over the world as it goes. And this is the reality today, that in many cases AI may not be able to do a good job even of in such simple tasks. It doesn't mean that it is useless, but what I'm saying is we are very far from world domination and AI eating up all jobs and so on. So we will talk about that as well. So it is important to understand three different types of AI that are there. We'll not get into too much detail. Uh, Narrow AI, where you train a program to do something and it can only do that. For example, you train it to play chess and now you want it to play Go or any other board game, for example. You have to retrain it. This is narrow AI. All AI today falls under narrow AI, including ChatGPT. But the desire is to have what is called a strong AI or general AI, where it has wide ranging abilities like human beings. So it is able to learn new tasks without forgetting old tasks and so on. And it can apply those learnings to different situations, etc. We are not there. We don't know whether we are going to be there or not and at what point of time. There are some people who are saying that ChatGPT version 5.0 has attained general AI status and so on. But this is all conjecture right now. I will believe only when I see it. But if you have AI, which is general AI, then super AI is not very far away, where it consumes all the knowledge that is available, replicates human cognition, does everything better than human beings, and so on. Um, More or less. So if general AI becomes a possibility, super AI definitely will happen. And that point at which super AI would happen would be called as inflection point. But what is this AI and how does it really work? And we hear about machine learning. How does machine learning really work? Let's take a quick look. If I ask you what is the next number in the series where x is the input, y is the output, and you would say, oh, you look at 1 and 1, you look at 2 and 4, 1 and 1, there could be a number of relationships, mathematical relationships satisfying input 1 and output 1. But when you look at 2 and 4, and then 5 and 25, it sort of becomes clear that this seems to be, output seems to be square of input. So 8 square would be 64. So you have looked at the previous data, And from the data, you have actually been able to infer something in the future that is happening, which is this number 8 and what should be its output. This is machine learning. You learn from past data and apply it to predict new data. I will give you now an example. On your screen, something will unfold slowly, and you have to tell, you can unmute yourself and tell very quickly what is the answer going to be. Okay, fastest fingers first. Do we have an answer? Anybody? Hey guys, quickly. No answers. Nobody is able to find out what's going to be there in the question mark.
So they cannot unmute themselves. So the answer
I
is coming
see.
at 3,
So they can
64,
probably
3,
put it in
3.
chat.
So yeah, the
Yes.
chat answers are 3, 64, 3, 3, 3,
Okay. Perfect. Thank you so much. I have
3.
no idea how you came up with those answers, but take a look at, you know, um, 12 divided by 4 gives you 3, 24 divided by 4 gives you 6, 36 divided by 4 gives you 9. So divide by 4 should be the answer, correct? And you would say, how about 52 by 4? Does it give you 7? Of course not. 81 divided by 4, does it give you 9? Yeah, no, it doesn't. So what has happened here? So I would suggest take a look at, for example, what is the answer for 24? It is 6. What is the answer for 42? It is 6. So 8 plus 1 and 1 plus 8 should give you 9. That is the answer. So essentially, the output is sum of the two digits or sum of the digits of input. That is what it is, right? So then it becomes 9. Wonderful. Now you see, when you looked at first three columns, you had one answer and you thought that is the correct answer. When you looked at the fourth column, you suddenly found that there is something wrong. But it is quite possible that somebody mistyped, and instead of 52 by 4 giving you 7, maybe it should have actually been 13. Somebody mistyped. It's possible to make a mistake, correct? But when you look at two more, then you realize that these are not matching, so there must be some other equation satisfying all of this. And this is machine learning. You try to identify patterns in the data, and you identify some pattern, and then you try to apply the same pattern to more data that is coming in, and you find that this pattern is not matching. You discard the pattern, you try to find another pattern, and this is all that is there to machine learning. Now, it gives us some very interesting insights into machine learning. One, in this case, what was happening? I already had the input and the output. Based on this input output, I was trying to find the pattern, right? So this is called as supervised learning, where I have an output and input, and I give it to an algorithm, and I say, for this input, this is the output, figure out the relationship. For this input, this is the output, figure out the relationship. This is called machine learning. But the lesson that you learn is that you need more data. The more data you have, the more you can try to figure out if I figured things out correctly, if I found right patterns. So the more and diverse data you have, better experience you have, better predictions you can make. This is the golden rule of machine learning. If you have to learn only one lesson in machine learning or AI, this is, especially machine learning, this is that lesson, that the more and diverse data you have, the better experience you would have, and hopefully better prediction you would have. So there are actually multiple types of AI. For example, search, optimization, reasoning, logic, and machine learning. So what you saw right now was machine learning. It is one way to implement AI. There are other ways to implement AI as well. So there are different types of learning. Supervised, we saw supervised. Then unsupervised, where you do not have a notion of output. You just give all the input and say, figure out some pattern from this data. So there is no output there. That is unsupervised learning. And there is reinforcement learning, which I would show you in a moment. Now, if you look at supervised, now supervised classification is one of the most widely used AI/ML application before ChatGPT. Now in ChatGPT, I believe transformers are, and they are the most widely used ones, and they use not just transformation, but a lot of other algorithms are part of the whole ChatGPT thing. But you can see, you can try to do object detection, trying to find out dog, cat, cycle, car, etc. Or you may try to identify exactly which pixels a particular shape makes, how many objects of one type are there, and so on. So there are a lot of different types of supervised classification. Reinforcement learning is also very interesting, where there is no data. You just leave the system to interact with the surroundings, and you say learn from it. You just tell the system that whenever you make a mistake, I will deduct 100 marks. And whenever you make a right move, I will probably give you 1 or 2 or 5, whatever marks. And in this way, the system makes mistakes and learns not to make those mistakes, does right things, and learn to do more of those right things. So there is learning from experience, and your AI is called as agent, which interacts with the environment and gets a reward or a penalty like you do. As a kid, when you do something good, your parents praise you, that is reward. When you do something bad, they scold you, that is the penalty. So you learn to do right things and avoid wrong things. Now, here is an example where it is used. Robotic vision, when you're playing games, chatbots, driverless cars, a lot of places where reinforcement learning is used. So let us take a look at, reinforcement learning applied to Atari breakout game, the paddle paddle game. Let's take a look at that. Please read what is on the screen very carefully. Okay. Oh, I'm sorry. I made a mistake. I will show you this video later. Um, this video is outside the PPT. Made a mistake there. You can actually, take a look on YouTube also. But once I'm done with it and you are asking me questions, I'll show you this video. Now, I'm sure all of you have heard about neural networks, and deep neural networks are very popular, and they have made AI possible today. The machine learning that you see, where you have a set of neurons, input and output, and a lot of hidden layers. Whenever you have more than one hidden layer, you call that as deep neural network. Let's not get into how neural networks work, and what are various architectures and so on. So let us not really worry so much about that. Okay. Now, input, output, and hidden layers. This is what it is, and neurons mimic human brain, or try to mimic human neurons. That's the whole idea behind learning. And right now, just know this, that it is because of deep neural networks that you are able to do a lot of things today. Success of machine learning today is because of that. Now, let me show you before we go further um, how machine learning in real life typically works. Okay, so I'm going to share another screen, and we will do some hands-on on that. Okay, so I'm going to take you to teachable machines. Okay, what is teachable machine? Can you see my screen? This is a teachable machine with google.com, and this is something from Google. So we'll do an image project where we are going to differentiate between a cat and a dog. So we want to train a system, do a machine learning project. We will show it a lot of different images of cats and different images of dogs, and then we will see if it is able to recognize cats and dogs. So I'm going to upload some images of cats and then some images of dogs. So class 1 I'm going to rename as cats, and class 2 I'm going to rename as dogs, right? So cat, of course, then I should be providing cat images. So let me provide some cat images. You can see that I have put some cat images. Now I can give some dog images as well. And I have provided some dog images, and then I'm going to do some magic. I'm going to train my model, right? And the model has been trained, and now we will test it. Okay, so how will we test it? By providing it with some more images and asking it, do you understand what this is? So I'm sorry, so I'm going to give this image, and I'm going to give this image to the model. I don't know why this is not taking the image, not a good thing. There's something wrong happened here. Okay, my mistake. Now I have to provide it with input, and here is the input. And what does it say? It detects it as a cat. 100% it's a cat. I give it another cat image, and let us see if we can detect that also as a cat. Yes. So that means our model has been trained and everything is good, right? No, what has happened? This dog is going to commit suicide. Our model is saying that this is 96% cat and 4% dog. Now, herein comes the challenge of AI systems. Unlike your traditional programming, they don't give you 100% result. They give you a probabilistic result. It is figuring out that 96% probability it is a cat and 4% probability it's a dog. Clearly, our system hasn't really worked well. Why is it being not recognized as a dog? Why is it being recognized as a cat? That's a $1 million question. But right now, we have no answer to that. Correct? So, for that, let us now go back. So what did I show you? I showed you using drag and drop. We did our first machine learning project. We were able to create a model. We were able to test the model, and we found the model was not good enough. Well, honestly, we gave only 4 or 5 images of cats and 4 or 5 images of dogs. We shouldn't really expect better results. If we probably gave it hundreds of images of different types of cats and different types of dogs, diverse data, more data, then we would have got some good results. But now let us go back to our presentation and see exactly this problem that we had. What is that problem? That problem is of explainability. I'm not able to explain why my AI is behaving the way it is. It is a non-deterministic system. It is a probabilistic system. Every time when you use different data, it can give you different results. That's why we call it as non-deterministic, and it gives you probabilistic results. So you need some mechanism where you can explain why the AI took the decision that it took. In case of safety critical systems, where privacy is important, where life-changing predictions or decisions need to be made, you need explainable AI. You can no longer treat your AI as black box. You need to have some mechanism by which you can say, why did it do what it did? So for example, one of these methods, especially useful for neural network based system, is GradCam. Now GradCam, for example, in this case, in the original image, having both a cat and a dog, when I asked GradCam, tell me what are the pixels that represent the cat most? And the deepest red means this is the most important one for cat. So you can see that the hind legs of cat, they are being used maximally and face minimally to say that this is a cat. Whereas for dog, it is the face of the dog which is being used maximally, those pixels which represent the face of the dog. And now, if you think that these are the right pixels that are being used, then you can say that yes, my AI is behaving in a correct manner. And if you think that is not correct, then it can help you determine your AI is not behaving correctly. So what do I really need to do? You probably need more data, different type of data. For example, in this case, you might want to test your system by using tiger and focusing on the hind legs of the tiger, because that might look very similar to a cat. and then see whether it is being recognized correctly or not. Similarly, a dog whose only small portion of face is visible, you get that kind of picture and test it. And then you train the model with those kind of images if it doesn't work correctly. So that is essentially explainability. To test AI systems, because they are non-predictable, um, they are probabilistic systems. There is one more problem with AI systems, that you do not have an oracle. What is an oracle? An oracle is nothing but mechanism by which you can get the expected result. Requirement, for example, serves as an oracle. Now, the problem with an oracle is that in AI, you may not have an oracle, because which images of cat and which images of dog, unless a human being actually does that, takes a look, says this is a dog, this is a cat, and so on, then only it can work. If you just give random images of cats and dogs, you cannot determine whether it's a cat or a dog. And that's an oracle problem. To solve this kind of a problem, you use back to back testing. Now, so to test AI systems, you need different test methods. And one of the methods or techniques is back to back testing, where you have two different systems and you run the system you want to build, and a system which may be slow, which may be heavy, which may be old, but you know it works correctly. So you basically give your input to the new system and the old system and do a comparison of both the results. This is called as back-to-back testing. It can be done if you have a pseudo oracle, which could be, as I said, an existing system or a competitor's product, and so on. Okay. Now, you also do what is called as metamorphic testing. In metamorphic testing, what you do is you have your input and then you change the input. For example, you go to Amazon, and Amazon gives you, for a price of an item of quantity 1, it says, let's say, 100 rupees. Now you don't know whether 100 rupees is correct or not, but whether this system is working correct or not, you can find out by choosing 2 items and the price should be 200 or less. Correct? If there's a discount. There's no discount, you choose 10 items, it should be original price into 10. So you change the input, you try to see corresponding change in the output. So you try to determine an input output relationship and accordingly keep changing the input and observe the changes in the output. That is called as metamorphic testing. Now, just to give you an example, um, when you change the order of numbers that are being averaged, your output should not change. Correct? So there is a metamorphic relation between output and input. So with the same number of inputs, exactly same inputs, you try to change the sequence of the inputs and you try to find out if you are getting the same output. If yes, then the system should be working correctly. And you try to do this with a large number of metamorphic relations. Okay. So that was how you test AI. There are a lot of other things. As I said, it's a uh, uh, ISTQB AI is a good course which tells you a lot of different techniques to test AI systems. And as I said, it is very challenging to test an AI system. But AI can be used to help in testing also? That's a question. And the answer to that is also yes, that AI can help you do testing also. We are not now talking about testing AI, but we are talking about how to use AI to help in testing. So it can help you in test planning, can help you in data augmentation, it can help you create test cases, it can help you generate additional test data. For example, my company AI Ensured has a product that actually does testing of the AI models, but it also allows you to do data creation, data augmentation, and so on. You can do impact analysis, test selection, defect prediction, right? A lot of different things can be done wherever you have sufficient amount of data, and that data leads to the output. Then essentially you can use AI. Otherwise, you cannot use AI. AI, there is no programming at all. When I say at all, I mean from a model perspective, you hardly do any programming. It is just that you take the data, clean it up, put and give it to a model, give it to a framework, for example TensorFlow, and say, Okay, create a model out of it using a particular algorithm, and you get the model. Since there is no specific programming, no specific if then else, the framework or the model learns the patterns by itself, then AI in testing can only be used where you have right type of data, otherwise it cannot be used. Of course, in test automation, there's a huge scope of using AI, and we will talk about that. So first of all, AI-based test data generation or augmentation. It is a very popular application. There are a lot of tools in the market today that are available, and more tools are coming up where you can use AI to create test data. I will give you a very interesting example. Let us say you want to simulate traffic. And how do you do that? One way is to basically go and stand with your camera, video camera at traffic intersection and essentially record the traffic. And in many of our projects, we have done that. Our customers have got us the video feeds from traffic junctions. We have worked in collaboration with the traffic department to test the systems or develop AI systems to detect traffic violations and so on. Now, that is one way. But today, if you look at it with deep fakes and so on, simulations, it is possible to describe the kind of videos that you want to generate so that you can then use that generated data in testing also. Similarly, so for one of our customers, we are doing data generation for insurance industry, where we get from them a lot of data, past data, and they try to calculate premium based on all that data. We feed that to our system and it generates more data because sometimes to test or sometimes to train AI systems, you need millions and millions of rows of data. And if you don't have that, then you need to generate that. So test data augmentation is one of the most important applications of using machine learning in testing. Okay, you will find it very interesting that those cats and dogs, if I rotate the cat by 180 degrees so that it is upside down, chances are that in many of such images, it will not be recognized as a cat. A human being will always recognize a cat, but a machine may not. So if I modify the data, existing data, rotate it by 90 degrees, 5 degrees, 180 degrees, 295 degrees, 255 degrees, in many of these cases, my system may fail to recognize. And this is also a part of that metamorphic testing and test data augmentation. But AI-based test automation is becoming very, very popular. Almost every tool now supports it. 3-4 years ago, 5 years ago, when we started doing this course, there were hardly any tools. All were new companies, uh, and they were using AI for test automation. But now the old companies also have caught up, and they've started using AI within that. So what you can do is use AI-based image classification, image detection, object detection to flag various types of defects, not only UI defects, but functional defects also, right? You run test cases and you mark them as pass or fail based on the result, and you get a false positive which says it is a fail, but it is not actually fail. So you tell the system, and then it basically improves and performs self-correction so that there are no more false positives. This is another example. Requirement document analysis using NLP, like ChatGPT, for example, can help you review the requirements, can help you generate the test cases, and we will see that very soon. So let us go to LLMs and how LLMs can be used for testing. Large language model, things like Bard, ChatGPT, Microsoft Bing, and which is now Copilot. So all of you, I assume, know how ChatGPT kind of AI models work. We typically call them as foundational models. They are built using huge amount of infrastructure and lot of data, and then you generate a model. On top of that model, you can use that model now for a lot of different domains. For example, same ChatGPT can be used to generate code, can be used to write letters, can be used to summarize paragraphs, can be used to write poems, and so on. right? So those are your large language models. Now, everybody understands that if you don't give proper prompts, you don't get proper outputs. So LLMs need carefully crafted prompts. I will give you just a few hints on what can be done there, and we will talk a little bit about how to test LLMs after that. So you need to tell the model what do you want. So you need to give precise instructions to the model, right? Then you tell the model that this is what I want to do, and now finish it. So the model basically takes a look at what you had asked it to do and tries to finish it. And if you want better results, you can also include examples or samples and say that this X gives you Y. Now, what will Z give you is basically demonstration. So, instruction, completion, and demonstration all should be provided as part of your prompt. Try to give unambiguous, concise prompt. You can actually give your prompt to ChatGPT and say clean it up, and ChatGPT can clean it up also for you. Eventually, what is going to happen is you will not need to do any cleanup. These large language models will actually be able to take your inputs, try to understand the context, clean up what you want, and provide you with required information. Now, here, in addition to clear instruction, you should also set the context. For example, you are playing this particular role. You are an expert um, expert teacher of philosophy, or you are an expert mathematician, or you are a novice, or you are an entrepreneur wanting to impress a client or get funding. So basically, you're trying to describe a role. So role and what are the activities that you do. That helps you set the context, and then you can provide the example. Take a look at this example. There is a quote by N.K. Jemisin, and the book name is The Fifth Season, and you say, okay, what is the author's name? Author's name is N.K. Jemisin. You give this as an example, and then when you give this kind of a quote and you ask the chat GPT kind of a thing, author, it fulfills, it completes what you had not completed. So this basically covers the instruction, completion, demonstration part. And okay, but what I said, answer as an expert, that when you ask it to behave like an expert, it will produce higher quality output as if it was written by an expert. Okay. You can also ask the model to say, write down the series of steps explaining your reasoning. And just by including that sentence, suddenly your answer becomes more precise, better, and so on. So it is very, very powerful. Third thing that I have seen happen, you tell the model, now take a deep breath, and do something, and the model produces better result. Now you might ask, model doesn't take any breath. Why is it producing a better result? Well, having gone through a lot of text, taking a deep breath, the model sort of, there's a pattern that they've analyzed, understood that taking a deep breath means look into things carefully, construct one by one, the reasoning. So basically give more thought to it, more processing power to it, and so on. So just imagine, people were surprised when, somebody gave a prompt, take a deep breath, and suddenly the quality of output improved. So essentially, if I summarize what I said, you need to define a persona and the task, set the context, give it an example, and tell it the format in which you want your results and what tone, and you will get your answer. So these 6 things: persona, task, context, example, which is also called as one shot or few shot learning, format, and tone. Now, I'm giving you homework. Just use any of the LLMs. Ask yourself, what, how are you going to write test cases using it? So give it a requirement, ask it to write test cases. Then take a test case, ask it to get into detail. or ask it to explain why did you write this test case, and so on. Play with different types of prompts, different styles of prompts, and see if you can produce better results. There are a lot of resources available. Um, Jason Arbon is one guy who's been relentlessly putting articles on LinkedIn and Medium and so on. Okay, so you can look at, for example, the second link that you see, AI testing of games using AI, Jason Arbon. So you would find his articles to be really interesting. I also did an experiment on LinkedIn. So if you search on LinkedIn with my name and an experiment LLM, you should be able to get that as well. You can use these LLMs for generating automation code also. Or if you've already written some automation code, you can give it to the um, uh, prompt and say, beautify it. You can also say, make it more logical, make it better, and it will, and explain to me why you've made the changes you've made, and you can become a better programmer also that way. So it's really interesting what these LLMs can really do for you. With that, I end today's session maybe 4 minutes early, but that gives us an opportunity to do question answers. So, Anil, how are we going to do the question answers?
They can post the questions in the chat and I will read it.
Perfect. Thank you so much.
So this question is from Sridhar Soleti. How testing is going to shape up in future because of AI?
Okay. So in future, maybe 10 years from now, 5 years, 10 years from now, we won't need testers to do regular run of the mill work. We will need testers to do things that something that only a human can determine. Otherwise, for most things, AI would be able to write code and AI would be able to test it also. It's only with respect to human related characteristics that you might need. For example, specific things like usability, right? That kind of stuff, or interesting security, etc. Creativity, I used to think that AI will not have creativity, but AI can generate music, AI can generate test cases, AI can generate code, it can give you reasoning. So, to a reasonable, if you are an average tester, your job would be taken by AI in 10 years time frame. So that a lot of automation using AI is going to happen. So that's another thing that you have to look at. So test cases, um, I would say, so, maybe I have gone overboard, but I would say, and this is an important question, so I'm taking more time here on this question. The important thing to understand is that AI is a tool today, and if you understand how to use the tool, you can do much better job. Faster, more efficient, better job. Like, using a spell checker, using a grammar checker, you can do better grammar. Similarly, using these tools, you will be able to do better testing. Now, any framework to test chatbots with respect to bias, hallucination, toxicity. Um, with respect to bias, you can use AI Ensured, which is our product. But hallucination, toxicity, I am not aware of any framework that actually allows you to do it. You have to write custom code today. We are developing some mechanisms there. So basically, what you have to do is distill out the facts. In fact, you would find that 3.5 ChatGPT doesn't have access to internet, but 4.0 now they have provided access to internet. You look at Copilot, it has access to internet. Bing has access to, Google Bard has access to internet. So you can pick up the facts out of it, feed it to another chatbot, and say, go search the internet, find if there is any hallucination, is this correct or not, and so on. Okay, so you can use two bots against each other also. So I hope that answers your question, Praveen, about Then the third question that I see, can AI replace Selenium, Playwright, and so on? Um, why do you want Selenium to be replaced? If AI is able to write code which can be run by Selenium, then Selenium doesn't need replacement, correct? But of course, there is other part of it that you have to look at. I believe that's what you meant, that it replaces human being in writing Selenium code and so on. Definitely, a human being can say, "Give me code for running on Selenium" and so on. But then there is something interesting. Jason Arbon, for example, had a product. Tariq King created a product. These are called as bots. They are able to crawl your UI and learn all possible paths using reinforcement learning. And then they can basically execute whatever paths you are interested in. So that's another aspect that you have to start looking at. How do we test an AI model? What is the strategy? Depending on what type of model it is, you start with data testing. Um, I'm sorry, Anil. Just give me a second. Where are the questions? Where is the chat window? Here. Okay. So to test an AI model, you need to understand where it is going to be used, what are the limitations of accuracy that you have, what is acceptable, what is not acceptable. It is a very important aspect. Then you have to look at what's the data I have. You start with data. So is the data cleaned up? Is the data biased? So you have to basically understand what does data bias really mean. You have to look at statistical distribution of the data. From there, you get into the kind of testing that you need to do at a broad level: metamorphic testing, back-to-back testing, A/B testing, and so on. And you need to look at the explainability. And from explainability, you need to figure out what all different type of data can be there. I have created a technique called extension to noun and verb, or linguistic analysis method technique. There is a YouTube video available on linguistic analysis method. Um, that technique is very useful in doing AI model testing. Then you have to basically look at how do you test regression in the model. So you have one model, you have another model. So you need to do some sort of automation, not using Selenium, etc., but either using API testing, or you have to write your custom code where you compare working of two models. So basically, back-to-back testing. And those are the kind of things that you need to look at. In our 4-day AI course, we basically discuss and show you a test strategy and how it can be done. And we also do hands-on testing on AI models and so on. AI testing certification and related training. Anil has shown you the dates: 9, 10, 16, 17 December, 4-day course. It's a hands-on course, probably around 2.5 to 3 days. You basically do a lot of hands-on. So there is theory, a day to day and a half, which covers the entire syllabus. And in addition, there is a lot of hands-on of creating models, testing them, and so on. The certification itself is theoretical based. Now, theoretical based could be scenario based also, but it is multiple choice kind of thing. It is not a hands-on where you are required to create a model and things like that. Okay. For ISTQB AI testing, nobody has published a book yet, unfortunately, and that is something that will happen. And in a year and a half, we are going to update the syllabus also. What is the learning path for testers to test applications powered by AI/ML? I would say go download the ISTQB foundation level syllabus for AI. So ISTQB CTAI, Certified Tester in AI. That is the name of the syllabus. Download the syllabus, read the syllabus. If possible, attend a training, because a trainer is going to provide you a lot of hands-on and so on. And if a trainer has experience of testing AI applications, for example, as I said, AI Ensured, our company, which does a lot of AI projects testing, as well as we have our own product for testing AI models. So you need to find somebody like that. I'm not just saying us, but anybody who has experience in testing AI. That trainer can help you gain better understanding of how to do it. After that, there is a lot of learning that we'll have to continue. So um, I hope that answers this question related to AI courses as well. Um, what are companies using AI testing? Well, any company which is using AI needs to do AI testing. For example, when I conduct these trainings, right from east part of the world to the west, Europe, North America, South America, um, Asia, everywhere, Malaysia, Indonesia, Singapore, Japan, Korea, US, Canada, right? Everywhere. Lot of different types of companies come for these courses. So you might ask, what kind of companies these are? So these could be your automotive companies, for example, working on driverless solutions or other things. These could be your pharmaceutical companies. These could be banking companies, insurance companies. I've trained all of these different types of companies on how to test AI solutions. These are new technology companies as well. Just think about it. If you see generative AI has been in use for quite some time, let's say Lenscard, and they take your face and then they show you different views of your face when you try out different specs or different frames. Now, does it work really well? That's an example of a startup which is heavily focused on eye care, but uses technology, uses AI, and hence needs testing. ChatGPT to assist in generating test cases by uploading requirements. So, security breach and so on. Actually, ChatGPT, for example, allows you to have a sandboxed environment, so you don't upload anything to ChatGPT. I know of, for example, there is a company which is automotive company, very big, and they have a ChatGPT implementation inside their company. So I don't know how much must have cost them, but now whatever data they provide to the model, it stays within the company, doesn't go outside, right? So that is something that you can actually look at. So these are alternate methods. Another alternate method is that instead of chat gpt you take a open source llm and then do training on top of that foundation model, which is very specific to your domain, and after that you can use it. So which means now you don't have any problem. You had an open source uh, model and you trained it on top of that, and all the data now stays within your company premises. So hopefully, Rama, that answers your question. Mohammed, you are asking about training schedule, plan on AI testing. Fees only Anil can tell. So I'm sure you can connect with him and he will help you with that. Who would benefit from AI testing course? Anybody who has to either do testing of AI applications, wants to understand what exactly is AI and how does it really work and what are the challenges, and then move into AI testing, or somebody who wants to use AI for testing. All such people would benefit from AI testing course. Engaging testing as a vertical for AI projects. I'll just give you my own example. Um, Infosys and Hexaware, they are two companies, for example, and we are talking to other companies as well who have tied up with us, who are our partners for our product, where they offer our product to their customers for AI testing and so on, right? Is AI testing cost effective and saves more time in producing test deliverables? Um, Depends on what you want to use it for. See, it is not magic. It is only as good as the data that you give to it. So, for example, if you are using AI for test selection, then you need to have good deal of data to enable that, and somebody needs to develop a tool. Such tools do not exist in the market in open source, a large number of such tools at least, where you can just take it and use it. Some things may be very specific to your company, may need data which is very specific to your company to further train the tool and so on. So if you use generic tools like ChatGPT, etc., or some other tools that I have given some references and so on, then you can save some time. Chat GPT can help you save a lot of time, especially it can act as your buddy and can help, when you're working from home, you don't have anybody else, it can help you there. However, understand one thing: today it may have limitations, tomorrow somebody is going to come up with a product which is very testing specific version of chat gpt, and then everything becomes much easier, right? Niranjan, yes, the courses are available online like you are attending this one. Similarly, the training would also be online. Can you get the recording of the session? Yes, you should be able to get the recording of the session. Right, Anil?
Yes, people. The recording will be shared in 2 to 3 days with all the registered participants.
Perfect. Any other question that you might have? Feel free to ask. Guys, I can just say one thing. AI revolution has just started. Unless government really clamps down on it, which I don't think they would, they are trying in some cases. For example, European Union is trying to come up with EU AI Act. Biden is trying to uh, Biden is trying to have his own proclamation, and a lot of other places. So forget about that part, you know, that there are going to be restrictions, but a lot of AI is going to be used. Now, if you don't understand how it is being used, you don't understand how it is done, then you'll not be able to test it. If you're not able to test it, you're out. If you are able to test it, that is one part. You say, I don't test AI because I don't use AI in my company. But then, can I use AI based tools? So you start learning today, reading more about the discussions and debates that are happening in the testing world about use of, LLMs for testing, pros and cons, and so on. At least read, even if you don't do, and do small experiments. There's no replacement of doing experiment on your own. Okay, so please do that. All right. Oh yes, AI can be used to compare information, but something that can be done more easily by uh, by conventional programming and conventional tools. Why would you want to use AI? Because AI is expensive. You need to train it, and then it consumes expensive resources. So please don't think that for everything I would need to use AI or can use AI. Sometimes the traditional solutions are the best. Test selection use case that I was referring to, sure. So let's say I have a large number of tests, and I would need to teach my AI that for this test, it does coverage of this code. And, when you teach the system that, then whenever there is change that has been made to the code, it will understand that, okay, this code has changed, which means these test cases need to be applied, and so on. So you basically feed it changes and feed it the test cases, changes and test cases, and also access to the entire source code and the mapping that you're doing. And then based on the changes, it would be able to do test selection. Uh, you can also feed it bug data, and especially bugs that were found in the field, or regression bugs, and so on. Based on that, it will be even more fine tuned, and so on. Not necessarily terabytes of data. Yeah. So the question is, do we need terabytes of data? No, not at all. Uh, Depends on, to consume terabytes of data, you will need to spend hundreds of thousands of dollars to consume that data and build a model out of it. You need megabytes, gigabytes, depending on what exactly you are trying to do. You need tens of thousands of records, millions of records. Sometimes you can do with less records also. How does that work? If there's already some bit of training that has happened, for example, let us say I trained a model which recognizes cats and dogs and 1000 species. Now I want to recognize 1000 species more. What I need to do is what is called as transfer learning. So I give it, or let's say now I need this model to be trained on 5 more species. Then what is called as transfer learning, I give those 5 more species not millions of images, but a few hundreds of images, maybe even a few dozens of images per class, and then I do transfer learning and it works well. So, but if you build something from scratch, yes, it might need, especially if you use neural networks, to achieve certain level of accuracy, they would need a lot of data. Without data, there is no AI. Which ML model would be best? You will develop your own, right? So typically, I would say, depending on the data that you're using, which algorithms, random forest, logistic regression, neural network based. These, for most things, people would say use neural networks, and that should really work out. Specific AI testing job opportunity, sorry, I don't know. In our company, of course, but we are full. But we have testers who test our AI product and also test AI models and so on. Yeah, so neural networks, basically from point of view of test selection and so on, neural networks are typically the ones that you would be using. You'd be using a LLM kind of a thing, feed it with the source code on top of. So this is, I'm forgetting the name, um, RAG. So you need to basically do that with test cases and code, and then your LLM can do that work. Okay. So I guess, guys, I'm out of time now. It's been a pleasure. I hope you enjoyed the session, and I hope to see you again sometime. We can do more discussions. Thank you, Mohammed that you liked the session. Thank you, guys.
Thank
Namaskar
you.
to all of you. May you all do well. Thanks, Anil, for arranging the
Thanks, Vipul.
session.
Thanks for the wonderful presentation and the insightful session. We thank all the attendees for your participation in the webinar. If you have any queries, you can drop a mail to trainings@veritysoftware.in. Trainings@veritysoftware.in. Thank you for your time and have a good day. Thank you.
Bye, guys. Enjoy.
Bye bye.